Labs. My name is Timothy Potler, and I want to introduce the basic idea of this lab, which is to understand um, velocity, specifically constant velocity, in the context of Newton's second law as well as his first law. And the lab uses both a computer simulation as well as a real life example to illustrate an object traveling at constant velocity. So, what are the real physics ideas? The main idea is kind of Newton's second law, which is F equals ma, and you can kind of see that the acceleration is kind of given as 0 since the problem specifies there's no change in speed or direction, and then F equals 0. And the reason F equals ma was used because as a way to kind of model this problem is because it does a good job of explaining an object with constant velocity since F and a equals 0 in this case. And Newton's first law also is talking about this case where it says an object in motion will remain in motion until acted upon by an outside force. So this is kind of that special case of the second law. And what are the actual experimental details? What we're kind of trying to model is a phone in my friend's hand who is moving it steadily across, and he's kind of holding it in the air at a constant height. We're going to kind of set the initial velocity to 0, but it'll go immediately to whatever velocity it is at, which I think is 0.025, and the initial position is defined as 0, 0, wherever that happens to be in the phone. And then the code is basically just modeling that by setting an initial position as 0, 0 and adding a constant velocity vector to that position every time delta that passes. And this is kind of the results you can see from the actual tracker. This is kind of the raw data that you get from that. So you can kind of see how my friend is moving the phone across the screen at one time. And this is kind of how the computational model looks. You can kind of see how the position is kind of a slope that is constant, and the velocity is just a flat line. That's because velocity is not increasing in position, and velocity is kind of the derivative of position, so that would make some sense in how that works. Position is just kind of a slope that increases at a constant rate. And then there's position and estimated position. You can see that they're largely pretty similar. There are some differences that's kind of due to some errors in my experiment that I'll kind of discuss right now. There's errors in how the phone was held. I didn't move it across the screen and at an exactly constant pace. Sometimes the force would kind of exceed what it should have been, and there were slight movements in the positive y direction that may have caused error. My phone went up a little bit over time, which I think was kind of the reason why the forces may not have been totally balanced. It also just has to do with control, which is difficult. And then if the axes were flipped, then the results of the experiment would be fundamentally the same, but position would be negative instead of positive. Velocity would still be constant, and the distance traveled would be equal. Velocity would also be negative instead of positive, but it would just, everything would just kind of be under the, would just kind of be reflected across the x-axis, but would be the same. But something like distance is going to be the exact same since it's a scalar. And then what does it mean? So, if you're asking about all the forces acting on an object, we can say, an object, it's kind of difficult to consider all the forces since there's just so many small forces like, gravity from many different areas acting on an object. But you could say the main forces are, the object's being pushed up by the hand and then pulled down by gravity, and it travels in the positive x direction due to a force from the hand, and the force against the hand is probably friction from the air. So those are kind of the main forces at play in this experiment. So yeah, that's all.